All right, so we found that that's positive. And if we plug in, we can pick another point, this time between -1 and 0. So let's pick -1/2. So we'll get -1/2 times -1/2 plus 4. That's 3 plus 1/2. And then -1/2 plus 1 is 1/2. So that's negative. And we know that when we're drawing a graph, it's going to go up to be positive, and then negative. And then the last part is our end behavior, which we can figure out in two ways. So either we can just plug in a number that's bigger than the roots or smaller than the roots. So the first way is check f of, we're going to pick a number bigger than all of the roots. So let's say f of 1. And that's going to tell us that f of 1 is 1 times 5 times 2, which is positive, and check a number that's smaller than all the roots. So we can plug in -5. And that's going to get us -5, -1, -4, and that's negative. So that'll tell us that as x goes to -infinity, we're getting large negative values. And as x goes to positive infinity, we're getting large positive values. The second way is to just use the table from 5.1. So we know that f of x has degree 3. So that means that the end behaviors are opposite in different directions. So if x is going to -infinity on one side, it's going to positive infinity on the other side. And the leading coefficient is also positive. So that's going to tell us that as we're going towards infinity, we're approaching infinity. And as we're going towards -infinity, since we have to be approaching the opposite, we're approaching -infinity. Which is exactly what the first check told us as well. That means our graph looks something like this. And that's really all there is to it for just end behavior. The idea is that if you plug in a number, like when we plugged in 1, we know there's no roots bigger than 0. So if it's positive at 1, it's going to have to stay positive the rest of the way. It can't go down to being negative, or else it would have had another root in there. And that's an idea that we'll put more formally in section 5.3. It's called the intermediate value theorem. All right, our next topic is going to be on changing signs, but we'll actually save that for the next video. It's a kind of maybe a trick that'll make it so we don't have to work so hard at plugging in different function values.